NetMaven. This video will continue to make progress on the inter-tenant communication and internet access. So first of all, in a node, we are going to make my requirement 1, that is the T1 and T3 communications, and T1 access internet via T3. The VXLAN multi-tenant design is very flexible for production environments, and it meets the various business and remains a simple, easy way to configure and understand. So T3 as a shared internet tenant in the data center 2 can be deployed with the public service like DNS, DHCP, NTP, etc. T3 serves for T1 and T2, and the T3, etc. multi-tenants for internet access. So whether leaking is required is based on the RT attributes between T1 and T2, T3, T4, etc. So leveraging the roadmaps is a ideal way to control some routes leaked into other tenants. So first we'll do configure on my DC1 leaf 1 and leaf 2. The leaf 2 will be configuring our tenant 3 on my DC1 leaf 1. So we just paste all the configuration required for tenant 3. Also of the configure required for DC1 leaf 2. This configure will make tenant 3 available in all the leaves at DC1. Then back to my leaf 1 will be making inter-tenant VRF, the RTs leaking into each other. So let's paste this. And so my DC1 leaf 2, I'll also paste on the leaf 1 3. So show run VRF tenant 1. We have configured the 1:200 leaking. 100 will be our AS number, 100, and 200 is defined for the RT attributes. But here main focus are still on at a DC2. Let's open up my DC2 leaf 1. At a DC2 leaf 1, we're going to show VRF tenant 1. I will already configure the VRF leaking. The VRF leaking will be 200 to 200. Same similarly on my border leaf. Show run VRF tenant 1. We're using 200 200, and if I show my tenant 3, also we're importing 200:200 also for EVPN. After this, we will be finding the DC1 can be leaking to DC2 because we will rewrite the AS number, rewrite through the super spine here and the BGW. But for the T1 and T3, they can be leaking to each other at the same site also. This is what we're trying to make inter-tenant communication right here. When multi-tenant communication is able to be leaked into each other, and we'll go focus on my DC2 border leaf. The border leaf will be populated default routes as a root type 5 in the T3. So if I go show RAM BGP, I'll be only seeing the default routes is advertised into the whole tenant, and I will be doing this router OSPF1. I will advertise a summarized router for tenant 1, and there will be at a tenant 3 level. I'm going to summarize the /24 routes to my DC2 WAN. After that, I will be advertising a summarized routes. So if I go to my DC2 WAN, I should be seeing a advertise the routes for tenant 1 subnet /24. When the default routes exist in the tenant, we're able to show IP routes at DC2 leaf, or be showing us the default routes actually leak into my tenant 1 routing table, and it is. And also we're seeing the default routes in my tenant 3 routing table also. At my border leaf DC2, I'll be able to see is T3 tenant 3 host routes leak into T1. So show IP routes 192.168.3.100. I want to see this specific route is already leaked into my tenant 1. And we'll see is a VXLAN leaked into my tenant 1 routing table. And vice versa, will show IP routes 192.168.1.100 VRF tenant 3. Tenant 3 will have the host route leak into my routing table of tenant 3. It is the host route for the host from DC1. For the host routes at the same DC 1.200, I can see there's a host routes in there in my tenant 3 routing table also. And the next, if I want to see, is my default router BGP VPN v4 unicast the default route at tenant 1 routing table. I will be able to see the tenant 1 routing table is from itself, imported from itself, and it's imported from itself from the tenant 3 into leaked into the tenant 1. This is the default route, how it's leaking on the same leaf between the tenants. Just one, just the column 5, that means my tenant VRF ID. That's 5 is tenant 3. This is imported from tenant 3 into tenant 1 routing table. So let's open up the DC2 T3XP host. What I want to show IP, it is host in tenant 3. So tenant 3, if I ping the other hosts, in tenant 1, I'm able to ping it, but notice the default TTL is 64, So it jumped like 3 hops to reach the same to reach the other hosting, other tenants on the same leaf. So the traffic is optimal routing. If I trace route, it goes to my border leaf and from T1 spine and border leaf and comes back a long way. So the communication between Inter-Tenant is via a border leaf. So what I try to better understand is that my traffic start with TTL 64 and it gets reduced 3 hops back to my TT back to my goes to my tenant 1 host and eventually the TTL reduced to 61 because in order to reach the other tenant host, it jumped to my leaf and comes a long way to reach my tenant 1 host. So go to my DC2 leaf 1 at this moment. Local leaves don't have specific routes with /22 routes to other tenants. What do I mean? I want to show IP routes 192.168.1.200 VRF tenant 3. Let's see how they're going to get routed. It gets routed to 66.6.6.6 to border leaf. And from the other side, I want to show you how to get routed to, for my tenant 1 host to tenant 3 host on the same leaf. And also gets routed to the leaf border leaf. What you get to know, the routes are coming from the EVPN. And what you notice is the tenant 1 is showing a tenant 1 subnet is showing a /24, and to reach out to the tenant 3 host, the leaf 1 will go to look for a default route. So that's why all the traffic all goes to the border leaf. And here, if I use T3 to ping internet, is pingable. That's all should supposed to be. And if I go to my T1 and if I want to ping the internet, I can ping also. So that's because I configured IPNet for this host at T1 tenant. What I configured is this IP static night translation for my host. So at this point, the T3, T1 are all able to ping the internet. So, but there's a suboptimal routing exists in the same leaf. So we want to fix this suboptimal routing. This only issue existing on the same leaf between the tenants. So we will at all leaf, we'll redistribute a local direct connector HMM routes and we'll use a route map to match all host routes only. So we're going to focus on my DC2 leaf 1. What I'm going to do, I'm going to IP prefix or make a prefix list. I'm going to deny all the other routes except the host route. So this is my IP prefix list and route map. I will define a denied first. I can define the route map. Then let's go to my BGP 200. That's into my tenant 1 and address table IPv4 unicast. I'll redistribute. This time, I'll redistribute HMM routes. Route map. And go to my tenant 3. Redistribute HMM route map. Same route map. Now let's show IP routes. In my tenant 3, if we can receive a /32 routes from it's actually from my BGP eBGP route. It is received from eBGP and it is /33 host route. What I want to show is the other way. If the tenant 1 received a /32 host route, and tenant 1 also received a /32 route. Actually, we want to do a ping. Let's see the traffic for Inter-Tenant directly via local leaf. Let's see the we can recognize it is from my ping TTL. Let's see if we just reduce one hop. So let's do ping 192.168.1.200, and now it just jumped one hop to the other tenant. Saying we can use trace route 192.168.1.200, and it's just one jump. It just routed. I see the butterfly in a picture. It's just the tenant from the tenant to other tenant is just one drop on the same leaf. So this HMM route redistribution will fix the suboptimal routing on the same leaf between tenants.